Alright, so let's focus on this question. The question is linked list cycle 2. So, in the earlier question, in linked list cycle, we talked about if the cycle exists, yes or no. So, that was a Boolean type question that we had to return in that question a true or a false. But here it's a little bit ahead of it, although the same logic, I would say. The only thing is that earlier I was telling that yes, the cycle exists, or no, it doesn't exist. Here I'm gonna tell from where it starts, because now the question says it exists, the cycle exists. Yeah, like, I mean, yeah, if there is no cycle, return a null, but if a cycle exists, then just tell from which node it's starting from, because of course there has to be a starting point in a linked list for a cycle. So yeah, that's all we have to tell, that from where the cycle is starting from. So how do we do that question? Do not modify the linked list, absolutely. So that has to be taken care of. And yeah, no cycle, then output no cycle. So yeah, if cycle begins, return the head or the node from where the cycle begins, and if there is no cycle, return null. All right. So how do we approach this question? First of all, let's do one thing. Yeah, let's do one thing. Let's assume that there is a cycle. Why assume? We have a example here. There exists a cycle. So both nodes at the starting head, fast. I mean slow right here, fast right here. Now slow right here, and fast right here. Now slow right here, and fast right here. So at -4 they will meet, right? At -4 they will meet. So that's something we know about. So the thing is, in a cycle these points are gonna meet somewhere. Yeah, in the cycle these points are gonna meet somewhere or the other. Cool. Now the thing is that if these points meet at 4, like this -4 node, yeah, we have to find out from where the cycle started from. Cool. So the basic thought process should be that, alright, at -4 my points are meeting. Cool. What I need to do is I need to figure out a way in which I can, find out the node where the cycle started from. How that can be executed is the thing. Yeah. So what we can do actually is we can say that if we are at -4, our fast and slow pointer met at -4, we need to reach at 2. Yeah, we need to reach at the node 2. How do we do that? Yeah, like, if we are able to tell that fast and slow pointer met at -4, so there exists a cycle because these two pointers met each other. How do we do something that two pointers meet at a particular node, so that we know that now this is the point from which the cycle actually started from? Yeah, because the thing is that if this distance from start till 2, if this distance is something x, for example, and from start of the node till the point where they met is m, this is x plus m. Yeah, and if we say that this whole thing till from the start of the node till the point where fast and slow pointer met is L, so L is equal to x plus m, for example. Yeah, and we can say that, alright, so from the position, like, now we need to find the distance from, like, the node from where the cycle started from, so that is basically the node 2. Yeah, so if I can find this x, I can find the node 2. Yeah, of course, if this if this x I know, this is the whole m and this is the whole L. From 3 to minus 4 is the whole L. So L minus m would give me x. Yeah, L minus m would give me x. But how do I relate that with it? That's what we are gonna do, of course, constant memory. So yeah, I mean, how, alright, so what I can be doing is that if I need this distance x for other node to meet at 2 as well, I need a distance x as well. From wherever I point it, if from head I will be traveling distance x to meet the point where it started from. I will be in the cycle, of course, now in the cycle, I will be, you know, pointing or putting my pointer at the node from where I would have to just travel x to reach at 2. If this is x, I need something in the cycle to reach at 2 in the x distance as well. And from what I can see right here is that yeah, if this is x, this whole thing can be x because it's like traversing like once. I mean, yeah, if this is x, this whole thing can be x as well. And if that's the case, then my placement of another pointer has to be at head, and the second pointer can be at the point where, or the node where fast and slow pointers met. Cool. Because if I have to travel x from here, I will have to travel x from here as well to meet at the same position together. So I can say the point where the first and the second pointer met is the point where from where the cycle starts from. Yeah. So this has to be x as well. So this has to be traveling x, but yeah. So I can place my first pointer at 3 and another pointer, the second pointer, at the place where fast and slow met. Here in this case that's minus 4. Because these two are gonna travel once only, and that is what x is, and that is where my both the pointers are gonna meet the node from where these cycles started from. Yeah. So how about that? What else can be done? I mean, this is one approach. I placed it at like minus 4 or something. I mean, the thing is, this thing can be derived very well. Like, you know, if slow is traveling x, fast is traveling 2x, so fast is 2x, then fast is also traveling, you know, the whole x plus m thing, and also, you know, gonna take circles in the cycle as well. So that's the length of the cycle into some variable. So if slow is traveling x plus m, fast is traveling 2 into x plus m, that is 2x plus 2m. But also fast is individually, if you look at fast is traveling x plus m, but also taking loops inside the cycle as well. So if the cycle's length is c, we can have the variable k numbering the loops. So k into c, you know, how many times it traverses in the cycle. So that is like 2x plus 2m equals to x plus m plus kc. That makes the whole c thing. If here it's 1, k is 1 because it's only one loop inside the cycle. If k is 1, then my x plus m equals c. Cool. My x plus from here till here m is equals to the c, that is length of the cycle. So if that's the length of the cycle, then yeah, that's c. So basically I'm saying that if this is m and this is c, c minus m will be giving me this. Cool. This whole c, this whole cycle's length minus m is gonna give me something. Yeah, it's gonna give me something that is this distance, and this x plus m, yeah, this x plus m is equals to L. Cool. That L minus m is giving me x. The c minus m is gonna give me something, but c and L were equal as I mentioned at the moment. Yeah, x plus m was c, x plus m is also L, so this is also gonna be x. Yeah. So all I need to do is I need to find out the distance x and place the pointer at the position where these two fast and slow pointers met. That's a good revision, I would say, of the approach I studied. So yeah, let's try to put this in the code. So first I need to find out that where the fast and slow pointer met, I guess, right? So I can say I can say, alright, a list node let's call it fast. Let's put it at head. Let's have something similar. My goodness, let's put it at head, that is slow. Let's try to implement the thing that we did previously. While fast is not equal null and fast dot next, we did discuss that why fast dot next is also needed for the null pointer check, null pointer exception check. To avoid that is null, then what we can do is we can say, alright, fast equals fast dot next, slow equals slow dot next. Yeah, cool. If fast equals slow, if that's equals to slow, what we can do is we can say return fast. Cool. Else return null. Yeah, now we know what fast is. Now we know where it met, like where these two pointers met. That's something. Alright, now we know it, they met at -4. All we need to do is so let's create a function separately that returns a node. Yeah, that returns a node, that is let's call it helper as well. Yeah, let's call it helper. It returns a node, no big deal. Yeah, it's gonna have something as fast, it's gonna have something as slow. I'm gonna cut this, put it right here, call this uh, helper function, call this helper function, wherein I put head and head for both. Yeah, fair enough. So this is gonna return fast if they meet. So this will be now carrying, so I can say uh, list node meet as this. Fair enough, sounds good. I can say list node meet, they met right here. So yeah, that's -4. I can say list node first, let's call it second. Yeah, list node first, what that can be is the head. Now all I have to do is have a while loop wherein I'm gonna be like, cool, now do one thing, traverse, like start moving ahead while fast while first not equal to second, while first not equals to second, first frst equals first dot next second equals second dot next. Yeah, while they both are not equal, keep moving ahead. Yeah, while they both are not equal, keep moving ahead. And if they get equal, then the while loop will end. If it ends, return any one of them. I'll say return first, but we need to make sure if this second becomes, null, if we get a null right here from helper, do one thing. Now that's gonna be the edge case check. If second equals null, return null. Cool, how about that? Let's see. It works. Alright, well done. So that was a quick revision of how to find out a cycle and from where it started from. So we used the helper function to find out the cycle. That's it. We returned, we modified the previous question a little bit. Instead of returning a boolean, we have a return, like a node return type. So I returned fast, that means they met right there. So yeah, had the edge case check in case they didn't meet. So just to avoid something as null.next, because here I'm doing that, make sure that they don't meet and keep moving ahead, but they meet, then return any one of them if that's your answer. Yep.